Hello, everyone, and welcome to the first Geothermal Rising Roundtable discussion organized by the Student Committee. The objective of today's discussion is to talk about how geothermal energy can contribute to climate change goals. We will first start by defining what is geothermal energy. We will also cover the environmental impact as well as the challenges, and we will also talk about the global perspectives. Our group today consists of engineers, geologists, geophysicists, AI experts, and this will only enrich more our conversation and help us understand geothermal from different perspectives. So before we dive into our conversation, I would like to open the floor for our panelists to tell us more about themselves, their countries. I know we are all from everywhere, their affiliation and their research interests. So I can start by myself. Hi, everyone. My name is Josiane Jello. I'm from Lebanon, but I am currently a student in the United States at the University of Illinois of Urbana-Champaign. I am a geotechnical engineer. My research topic focuses on energy storage in the subsurface. So what I'm trying to do is to take external heat and try to increase the temperature of an existing reservoir.
Thank you for the great introduction. Hello, everyone. It's a pleasure to be part of this discussion. I'm Ahmed Al-Islambouli. I'm originally from Egypt. I'm currently doing my PhD studies at Khalifa University in the United Arab Emirates. I'm a geophysicist by background, but currently I'm working more on CO2 monitoring in the subsurface and related fluid monitoring topics. Pleasure to be here. Thank you.
Hi, yeah,
right,
thank you,
I'll go
Josiane.
next.
Oh, do you want to go?
You go ahead, Laura.
Oh, hi, I'm Laura. Thank you for hosting, Josiane. So I'm a geologist by background. I'm originally from the UK, but I'm doing a PhD in New Zealand, in Wellington. I'm primarily looking at sort of the magmatic systems around the North Island of New Zealand and how the magmatic systems relate to the geothermal systems.
Perfect. My name is Mohammed Al-Jubran, and I'm a third-year PhD student at Stanford University, working with Professor Roland Horn in the Stanford Geothermal program. And my focus is on the modeling and optimization of flexible geothermal power systems and storage. And my background comes from about 4 years of experience in oil and gas, working as a drilling engineer and a computational researcher, as well as a data scientist. So that's what I'm leveraging here to the geothermal industry, and it's a pleasure to be here.
Thank you all for your introductions. So let's start with our discussion. First, we're gonna again discuss what is geothermal energy. So what are the fundamental principles behind geothermal energy, and how does it differ from other renewable sources such as solar energy and wind energy?
Maybe I can go ahead for this one and start the topic. The fundamental principle is very simple. It's just the heat stored in the subsurface. And the good part about it, it's available everywhere. It's beneath us. It can be found anywhere. But you have to keep in mind that the capacity that's available in the subsurface may differ from another to another location, from a basin to another, and it depends on the mechanism of the subsurface and how the heat is transferred along these subsurface layers. How it differs, the very good point that you can think of, it's available all the time, 24/7. It harvens all along the day, all along the year, and that makes it much advantage than the other renewable sources, where you have to be keeping in mind the season, how much capacity, how often is the sun is there. So it's more reliable.
Exactly. So like when we talk about solar energy, we need to think about the intensity, the time of the day, the seasons, as Ahmed explained. For the wind energy, we need to focus on the do we have wind? What is the intensity of the wind, and so on. But when we talk about geothermal energy, we know as we go deeper in the ground, the temperature becomes more and more stable, and this makes it more reliable, non-dispatchable, so it's available all the time.
Yeah, I think one aspect I could further highlight, like you guys said here, is that geothermal is a naturally base load type of supply profile resource, besides it being clean. And this is a distinctive feature of it compared to intermittent resources such as solar and wind, which are weather dependent with different seasonalities, solar being daily seasonality, as well as seasonal over months or seasons, seasonality or frequency, and wind depending on location. And for us to really get cleaner, and in terms of our power supply, decarbonizing our grids, it really matters to make sure that we do have a baseload resource to make sure that we don't really run into blackouts here and there. And geothermal really provides that. So it's a really important aspect of grid reliability that geothermal can provide.
Yes. So from energy engineering perspective, what are the key challenges and innovations in harnessing geothermal energy for sustainable power generation?
So perhaps one key challenge is that you're always dealing with when you speak about geothermal. Most of the time, if you didn't like a low or medium temperature gradient, you would have to go really deep. It can exceed to 4 kilometers where you have low imaging resolution, or maybe other associated challenges with drilling and producing these hot fluids. And you need to bring these hot fluids all the way to the surface. You need to make a good circulation for the geothermal, and it becomes more challenging as you go deeper in depth.
So the main, I would if I want to comment on this, the main challenge is the cost, because as Ahmed was explaining, as you sometimes we don't have high temperatures close to the surface, so we'll have to go deeper. And as we go deeper, the price would increase more and more and more. One innovation is that, so part of my research topic is also to utilize existing hydrocarbon wells. So one solution to address the cost is to reutilize these wells, because as we know, at some point a hydrocarbon well would be abandoned and will just stay there. And it's just a well, it's drilled, it's available for us. So if we can do more analysis about the subsurface, we can reutilize and repurpose these existing wells.
I'd just like to add in here that I think that it's not just about drilling deeper that we think about an engineering perspective. As engineering advances, we can actually access and utilize even lower temperature geothermal resources that we might not have been able to access before. So that's another engineering sort of advancement where we can utilize more geothermal resources.
Yes, and one thing to add up when you're speaking about hydrocarbon, keep in mind mostly these hydrocarbons, they're available between 60 to 120 temperatures, and which is the favorable temperature window for hydrocarbons exploration. But for geothermal, you're looking for deeper and deeper source, and then maybe this knowledge from oil and gas is not enough, and you need to expand the knowledge that you pretty acquired from the hydrocarbons and apply it deeper and more.
Yeah, that is true. And another challenge I would like to add is that sometimes you have a hot reservoir, but you do not have a good fracture network to be able to circulate fluid and extract that heat from it. And one solution for that is that there is currently lots of research going on in enhanced geothermal system, where you create your own fracture network to be able to extract that energy that is stored in those low permeable reservoirs. So this would lead us to our next question. Geothermal energy as we were discussing, relies on the subsurface conditions. So how does the geology of a region affect the feasibility and efficiency of a geothermal project?
So I might take this first and just sort of talk about the large scale. And ultimately, the sort of availability of geothermal resources depends on your tectonic setting. So in places like where you've got volcanoes and where you've got a very active tectonic setting like New Zealand or Iceland or Japan, you tend to get a lot of geothermal systems, and you get some really high temperature geothermal systems that you can access. But you can also get geothermal resources in places that haven't experienced active tectonics in a while. So for example, in the UK, where you're pretty geologically stable at the moment, they're producing geothermal energy down in Cornwall from a granite that was active or emplaced about 300 million years ago. So it's not just that we can utilize geothermal resources in really active areas. We can really expand that to more areas that you perhaps wouldn't think about.
Yes, and it's quite a unique point of interest to research nowadays, which is how do you utilize different temperatures, which can be divided in magmatic or amagmatic systems. Magmatic when you have a magma source very close to the surface, or maybe relatively deeper, or where you don't have it. So currently there's a lot of research looking into how you utilize any basin with whatever temperature and how you use it for geothermal, which is very, very similar concept to what we're doing for hydrocarbon. We're trying to get more knowledge from techniques that has been applied to hydrocarbon and explore the subsurface conditions which can be suitable. But however, the aim or the target is different. So maybe for hydrocarbon, we're looking for accumulations, we're looking for a trap, we're looking for a system. But for geothermal, we're looking more in the fluid availability, good permeability, and good hydrological dynamic.
I may chime in. It's also a question of the economics of the resource. There's always that uncertainty surrounding any particular resource, and trying to understand the geology of it and what the temperature could be like. And that could really govern the likelihood of you really successfully developing such a high upfront cost project such as geothermal. If you run into the situation where you estimate at 150 Celsius and then you drill down there and you land on like a 110 or so, then this could be dramatically disadvantageous, despite you landing something that is feasible to generate power through, you know, subcritical or otherwise binary power plants. It could still be not feasible to continue going forward. So I think capturing that uncertainty and being able to really predict with good accuracy and certainty the temperature of the resource, since that's the one component that you could always bargain on, given that you can go EGS, you can fracture, you can pump fluid, so you have your water and fracture network. If you have that temperature with good certainty, then you could really attract a lot of investments, especially with such a high upfront cost, where people want to land their return on investment of like 10, 15%. If you tell them that you're not really sure, and that's all you're providing, about 10, 15%, then investors are not as excited, and hence you don't get as many projects being developed in geothermal. Hence we kind of need to iron that out and be a little more robust and confident in those predictions down at the subsurface.
So, Mohammed, a follow-up question on this is, how can we utilize artificial intelligence to enhance our exploration and management of geothermal resources?
Beautiful. We have a very interesting, that's a very good question. We have a very interesting project that's going on, as a matter of fact, right now in the Stanford Geothermal program, and I'm heavily involved in that one. It's all about using artificial intelligence, but for the prediction of subsurface temperatures. We're trying to develop a 3D model for the entire United States. Now, if you think about it, the most famously available temperature at depth map nowadays is the one for the United States, is the one developed by Southern Methodist University. And if you can look it up, and then you'll find that they provide it for a few depths, starting 3.5 kilometers and deeper, not for shallower depths. So those maps were developed to only capture conduction-based heat dynamics, not convective upflow, which are kind of the zones that developers want to capture, as a matter of fact. And for different reasons, they didn't capture that. They kind of put aside that data. They just collected bottom hole temperature data. They made some predictions using different statistical techniques, not artificial intelligence. So what's going on in the project I'm talking about is that we're using graph neural networks, and we're capturing about 500,000 bottom hole temperature measurements. We're including magnetic anomalies, gravity anomalies, elevation, sediment thickness, and other kind of properties. And I'm focusing on this just to kind of be hands-on and give an example to map out temperature at depth. So if you have that at a higher accuracy and it's nationwide, then you could really encourage a lot of these projects to pursue more specific acreage and say, hey, you know what, I can go to this acreage about 10 square kilometers with confidence that I have plus minus 150 Celsius sitting exactly around that depth of, say, 3 kilometers plus minus whatever, 100, 200 meters. So this can be really impactful. And this is from the, let's say, subsurface geology side of things. Now, the world of artificial intelligence has conquered a lot of problems in oil and gas when it comes to reservoir management, well placement and optimization, forecasting the production profiles of your wells, temperature decline in the case of geothermal. There are a few papers here and there. Drilling optimization when it comes to your rate of penetration, et cetera, et cetera. So artificial intelligence could really chime in and tackle a lot of these problems with good, I guess, record of effectiveness, be it in geothermal or equivalent problems that have been demonstrated in the oil and gas literature as well.
That's really interesting. So can the model also predict temperatures at shallower depths? The one that is being developed at Stanford?
Yes, we're about to publish this one in a few weeks. As a matter of fact, I'm happy to send it across. It'll be able to predict temperatures from wherever you're standing in the United States all the way down to 7 kilometers.
Nice. Well, that's really cool. And so we already covered what is geothermal energy. I'm going to move now to the environmental benefits of geothermal energy and the current challenges. So we know that geothermal energy can provide both electricity and direct heating and cooling applications. How can this versatility help address climate change goals? So I can start by giving an example, which is UIUC. At UIUC, we have currently several projects. For example, in the building that I'm currently in, we connected 2 buildings with a bridge, and the bridge piers, or like the foundation of the bridge, had geothermal loops. So we had like energy piles, and those energy piles are being utilized to heat and cool the geotechnical lab. We also have another building that is being supplied. So we have a field that has around 64 boreholes, and those boreholes are being utilized to heat and cool an entire building. So, the analysis showed that utilizing these energy foundations can decrease a lot the CO2 emissions, and this can contribute to, can help the university to reach their climate goals.
I can chime in. This is a great example on district heating and cooling, like you mentioned there. There's also the power market side of thing that I'd like to comment on, which is all about, it used to be that demand is variable and supply is stable, since we're like quite dependent on natural gas, which is just available, dispatchable 24/7, right? So it's a firm resource when it comes to power. But nowadays we have those intermittent resources like solar and wind, et cetera, et cetera. And our problem right now is that supply is variable, demand is variable. We're trying to shift the supply to times of the day when we don't have those cheaply available clean resources like solar. So what we're looking for is some clean, firm resources. Now, some works are talking about using storage, which is a thing that's being used nowadays. But the issue with, let's talk about electrochemical storage and particular, you can shift your solar by a few hours in the day, but that's as far as you can go. After that, the economics start breaking down. It becomes too expensive to store using the state-of-the-art technology and even what's forecasted for the next few years. That's why people are starting to look at other forms of storage, because one of the biggest shifts that's needed is not just the daily shift from the daytime where we have excessive solar. In California, power prices are going negative, as a matter of fact, because we have too much solar in the daytime. And they're saying, hey, you know what? I'll take your energy, but I have to pay me money as well. So you're actually, exactly, right? So it's going negative. So it's kind of ridiculous, as a matter of fact, that we find ourselves in this position. Hence, we have to curtail, literally dump power or energy in the air, right, with no use. And in the on-peak hours in the nighttime, we just don't have energy. And then we try to burn more natural gas. That's one. And the other one is shifting from the seasons where we have abundance of energy, like the spring in California, you have quite a bit of hydro, water is running, and we have quite a bit of solar. But then the summertime, we turn on the AC, there's a lot of demand. There's not much, there is solar, but the efficiency of power plants, all of them just drops because temperature is higher, ambient temperature, and you don't have hydro, and hence you find yourself in lack of supply. So the question is also shifting, like what you talked about earlier, with like maybe thermal storage underground, shifting the supply across seasons to the summertime. So I think these kind of technologies that make flexible geothermal energy. We have a couple of projects working on that to make geothermal flexible. Fervo Energy proposed what they called Fervo Flex, where they would charge their fracture network at some times of the year and then discharge it at other times when it's more needed to make their profile instead of base load flexible, and really trying to match the net load needed given our current kind of energy mix and power market. So I think these kind of technologies are pretty important, effective in fighting climate change.
And this is actually what I'm currently... Oh, go ahead.
Thank you. Can I just take this in a slightly different direction? So thinking about the versatility of geothermal is that you can use the direct heating. So we've talked about using for heating for building and cooling buildings, but you can also use it for industrial purposes. So in New Zealand, there are a couple of companies that are using the direct heat for like the drying of timber and the drying down of milk, and so that sort of thing. So I think it's really important to think about not just the generation of the electricity, which you also get from solar and from tidal and from wind, but you have this direct heat that we can utilize quite a bit more than I think we currently are.
Yeah, very interesting. And can someone give us an example of an existing successful geothermal project around the world, and what are the lessons that we learned from this?
I can jump in here. So in New Zealand, we have the Wairaki geothermal power station, which is the second geothermal plant in the world. And so because New Zealand is quite pioneering in terms of geothermal research, they noticed that there were some problems when you first started extracting, such as subsidence, sort of well depressurization. So they noticed this quite early on in the history of the geothermal plant. And so you've got to come up with sort of ways to fix this. And one of those ways is sort of thinking about reinjection. So the reinjection of the extracted geothermal water and putting it back into the reservoir to try and maintain well pressure, and ultimately leading to this sort of being a more sort of sustainable, considered renewable energy.
And what are the environmental impact of geothermal energy compared to other renewable sources such as solar and wind? I can start with
perhaps the most. Yeah, go ahead, please.
No, I just wanted to say a very simple difference between these resources. For example, geothermal energy, in terms of land, takes a much less area compared to solar and wind energy. Because for solar and wind energy, we need to build large fields to be able to generate enough power.
Yes, thank you. That's a very good point, Pai. If you may think about geothermal, one very big concern that you have to keep in mind is the seismicity. Seismicity is one of the biggest concerns that everyone in the industry careful with, because you don't want to induce all the fractures or reactivate the faults that's already there and cause high earthquake magnitudes. So these has to be paid attention and treated with careness. And that's a very big risk that you have to be careful with, because as you're producing high energy, you're going to be producing more and more fluids. The subsurface is in equilibrium, but you actually affecting this equilibrium, causing heterogeneity in the subsurface in terms of pressures, and it's going to result in some action back.
This is true. In fact, like the seminars this semester at the university were all about induced seismicity. So geothermal resources are often concentrated in specific regions. How can international collaboration and knowledge sharing help make geothermal energy more accessible and widespread? One example of this round table. So we are all from different places and we're like talking, we're listening to each other, sharing our own perspective. So I guess that's one example. GR, the student committee, is another example where we all meet from different backgrounds and we just share our knowledge, talk more about geothermal energy.
Yes, but you have to keep in mind that industry is still immature in a term.
Definitely,
you see different companies coming up with different technologies. Most of these results or experiments are still unpublished. You don't see much collaboration between different sites across the world. So it's still immature in terms of knowledge and techniques. And I think there is high collaboration needed for geothermal energy to advance forward. You need to get different lessons from different parts, and it can take us in a faster pace to achieve more projects and successfulness.
Yeah, so just jumping on the back of what you've said, Ahmed, is a good example of how sharing of knowledge can help. So within New Zealand, we have a geothermal plant called Natha, and it's now New Zealand's first zero carbon geothermal power plant. And this power station was emitting quite a lot of CO2 and having to pay back to the government quite a lot of money for emitting so much CO2 per energy amount produced. And because of the sharing of IP from a plant in Hawaii, they were able to use their knowledge and sort of methodology to apply it in New Zealand, so that they can sort of keep running and now be the first zero carbon geothermal plant. So it is possible, and people, yeah, you can do it. We just need more collaboration and more people willing to share their information.
Thank you, Laura. So now we're going to move to discuss more about the global perspectives. So for students from different parts of the world, how does the potential for geothermal energy differ in their respective regions, and what unique opportunities and challenges exist in their areas? So I can start by talking about the Midwest. So in the Midwest, the subsurface is characterized by being low temperature energy, meaning that if we want to use it for power generation, we need to go really deep in the subsurface to be able to have like those high temperatures that are used for power generation. What we've been trying to investigate here in Illinois Basin is we're trying to increase the temperature of that subsurface, meaning we're trying to create our own artificial geothermal reservoir by taking heat, as Muhammad was discussing earlier. He was talking about in California, solar energy is generating lots of energy during the day, and existing thermal storage systems become expensive at some point. So what we're trying to do here in Illinois is to take that excess energy from other resources such as solar energy and store it in that low temperature reservoir to be able to increase its temperature to values where it becomes feasible for power generation. I guess in New Zealand is mostly like, because you use it more for like power generation, you don't need to go as deep.
Yeah, so in New Zealand, most of the geothermal wells at the moment are drilled below 3 kilometers. Sorry, above 3 kilometers. But in New Zealand, we have sort of unique opportunity, similar to, again, Iceland or sort of the US, that you can think about what you call supercritical geothermal resources, which are essentially really high temperature resources over 373 degrees. And these bring their own challenges in terms of engineering, having to drill much deeper. But yeah, it's a really unique opportunity, and you can get so much more because they're so much hotter. You can get so much more energy out of them per the amount extracted. So if we can get it working, that provides so much more for New Zealand in terms of the energy potential for geothermal.
If I may follow up here, I think these are really good points, Jose and Laura. It kind of bridges the point earlier you guys made about knowledge sharing and collaboration. So it's, I think, very easy to find yourself stuck in a technical pigeonhole, in a sense, focused on the very same or specific problem that you have in your area or region. And in a sense, forgetting about what's going on around the world of other end-use cases that geothermal could really play in. Like an example, I'm stationed in California, and we talk a lot about electrification and just decarbonizing the grid. And when we talk about geothermal, even though you only get a 10% efficiency in your conversion from that exergy from the heat from underground to electricity, but we still are talking about this. That's our main focus. And electrify, vehicles as well and stuff like that. Now, I was in Beijing for the World Geothermal Congress, and I was shocked that, hey, you know what? A lot of the talk out there was about the collaboration between green energy from Iceland, transfer knowledge from their experience in geothermal to China, where their district heating industry is, in a sense, booming when it comes to geothermal, serving that as a supply source. And I was like, wow. So like the vast majority of their efforts were focused on that. And then, I was just right after that, I got approached by people from New Zealand, as a matter of fact, in a company called Upflow. They do technical consulting, and they were wondering about some work that we do in terms of flexible geothermal. And they said, we have this New Zealand battery project, and we're thinking of shifting the supply as well. Maybe geothermal, hydro, et cetera, since they have some dry seasons every now and then, and they need to shift supply as well in a different form, in a sense. And they were like, can we generate hydrogen out of that? What are the techno-economics of it? And then the work we did, we kind of pushed the paper in that direction on really the techno-economics of that. So it turns out that as you turn your head around and get that opportunity to explore other challenges that could be tackled through geothermal, then you realize that the story is really big and the potential is really large and the room for collaboration is just vast, and you want to invest in that.
So as students here and as being the next generation of engineers that will be working on geothermal energy, how do you think education and research institution can prepare us better in terms of geothermal energy and our contribution to climate change goals?
I like to say it's about pushing more of those open source tools, data, knowledge. That's what happens in the industry. It's kind of natural that businesses try to compete. They try to, keep data to themselves a lot. And this isolates the, different groups of data from being integrated to come up with a bigger model that really makes more sense than what a single company has. And I think in academia, you do have that privilege as soon as you manage to access some of that data one way or another, that you don't have that interest of keeping the data to yourself, right? Rather, you want to push it out, whatever tool you have, you put it on GitHub. And that is very, very, very helpful to people in academia if others do it, and to others if people in academia do it, which is exactly the case. I would love for the industry to do more of that knowledge sharing because it helps everyone.
Yeah, that is true. And as we know, the deployment in geothermal energy lags compared to other resources. What policy and financial incentives do you think are needed to promote the faster development of geothermal energy and its integration to the grid? So,
Okay,
yeah,
I
go
can take
ahead.
this one because nowadays you see many initiatives going around from different countries trying to introduce the carbon credit. So maybe for the US, there is currently no carbon taxes or credit going on, but they're working on it, and it will be soon introduced. And this is going to be a big motivation for different companies or sector to invest in geothermal, where you can gain carbon credit and it lowered the taxes for you. So this is a very good initiative, and it motivates the industrial sector to be investing more and more in clean renewable energy, especially with geothermal.
And
I want to.
yeah.
I'll start. Go ahead. You're saying.
No, go ahead.
Oh, thank you. I wanted to add to the point that Ahmed mentioned, which I find very, very interesting and relevant. In the US market, they have been working on production tax credits and investment tax credits. And the nature of those, investment tax credit, pretty much about 30% of whatever you put in, you get a tax credit in terms of your capex, equivalent to 30% of that given to you. Production tax credit is some dollars per megawatt hours you generate your fixture, you get that. So just like a context in there. Now, recently, geothermal was included in those taxes through the Inflation Reduction Act, which is pretty good. Now, there are still complaints from the industry about this process and the challenge that goes along with it. And it's about policymaking. So the challenge here is that it's not cash that you get. If you opt for investment tax credit, you don't really get a lump of tax that you put in your account and you go like, hey, you know what, that's my cash flow right now. Rather, it's a tax credit that you have to chase and try to acquire over a period of time, and only comes kind of drip by drip over time. And that process is not straightforward to people. I was chatting with people from Fervo and a couple other companies, and they were like trying to educate us on how this is really a challenge to them, and working that out with the government, making it easier, would help them quite a lot in expanding on geothermal capacities in their areas.
Looking on that, we know that community engagement and is very important in advancing any technology. Regarding geothermal energy, how do you think we can promote it better to our local communities around us? So I just want to comment on that. So before Ahmad was mentioning induced seismicity, and there has been some cases where geothermal application induced some seismicity in the area. I would say that like these type of incidents can reduce the community acceptance to geothermal energy.
Yeah, so I'll add on to that. So I think in terms of community engagement and getting the local area involved in sort of a geothermal project is really important to involve them at the start. And so be really open with what you're planning on doing, and what the possible I guess sort of the pros and cons and what possible impacts there might be. Because if you start a project and then you come to it and then you say, oh, this is what we're going to do, then they don't feel as involved, and they're probably not going to quite understand, and it would have been really good to get input much earlier on in the process. And the other thing might be sort of talking about cascade uses of geothermal. So what we were talking about earlier, where you can use the direct heat. So if you have sort of where I talked about earlier in New Zealand, we have wood companies and milk companies that use the direct heat. You can actually bring businesses and jobs and bring money into the community that way via geothermal. So if you include communities at the start, then you could build something potentially much bigger than just an energy plant. You can sort of, so what we've got in New Zealand at the moment, they're working on a sort of eco geothermal park, and they're hoping to bring lots of some local businesses and things to use the direct heating applications. And so this is a much sort of bigger, wider reaching effect than if you hadn't included the local community at the start.
And I would like to also take that question to a different direction, which is heating and cooling applications. So one way to increase the community engagement regarding heating and cooling applications is to like, for example, on campus here, we have many projects, and these projects being successful can help the community gain more confidence in these technologies. And by this way, we will promote more and more these systems.
I think the biggest motivation that we can do to people is to raise awareness. If people are aware of what conventional methods is doing to pollute in the air and pollute in our environment, they're going to be motivated to really join on the geothermal, because geothermal is clean and it has a lot of advantages. Yes, every single energy comes with risks or environmental impact, but we have to think of what is the good points and why we proceeding in these. And that's when you raise awareness and you make people really aware of what you're doing and how much you cleaning your globe. They're going to be part of it. They're going to feel engaged in it, and they're going to be much supportive.
Thank you, Ahmad. So to conclude our discussion today, I would like to ask each one of you to give me, like, what would be your advice for the students who want to pursue a career or a future in geothermal energy? So I can start.
I can start here.
Yeah, all right, go ahead.
Oh,
No, go
all right.
ahead.
Cool, thank you. Appreciate it. Appreciate it. So I have a brief one. I think it's important to, since I personally did not start my career in geothermal, even my master's, I got my master's, only maybe like some 30% was in geothermal. But then I decided, hey, you know what? I think I'm going to do my PhD in geothermal. And I think what motivated me was that I realized, I was kind of keeping track of what's going on in terms of the different energy resources that are coming to expanding capacities and the problems they are facing, like solar and whatnot, like we talked about just now. And I realized that hey, you know what, this is the kind of role that geothermal can play, and we know it's down there. We just need to be able to extract it in a economically viable manner. If we can get there, then this is the kind of impact it can make. So I think the tip I'm trying to convey here is try to develop an understanding of what geothermal can be in a given application or two or more, and then what you want to do to make that, viable and make it materialize in that direction that you find interesting to yourself.
So
I think I can add up. Yeah.
Okay.
Yeah, please go ahead. Go ahead.
So my advice would be for the civil engineers who would want to pursue some career in renewable energy. So when I started and when I came to the US, I had no clue what geothermal energy is. I did not have any background in thermodynamics or heat transfer and these type of processes. But my advice would be, do not be afraid. You will learn as you go. It's very interesting, and the more you work on it, the more you see like the impact that it can have and the potential that it can have. So go for it and don't be afraid.
I think you add in very good, valuable points here. But my advice would be more focused on geoscientists. So most of the geoscientists, they're really scared with the industry, geothermal industry, seeing it small. It's still relatively small compared to hydrocarbon industry or any other energy industries, and they're really worried, like, if I pursue a career in geothermal, am I going to be able to shift later on? Well, to be honest, you're doing the same thing when you're dealing with geoscience. You're dealing with the subsurface, so you're dealing with the same conditions, but the objectives are different. So you have to be really careful with your skills, how you develop them, and you have to understand what's your objective, whether you're working for geothermal or any different subsurface energy.
So I'd answer that in a bit more of a broad sense, as you've just talked about the sort of geoscientist aspect. Is that there are so many routes into sort of being in a geothermal career, right? So we have someone who's AI, we've got a geologist, we've got a geophysicist, we've got engineers, and you need chemists and you need physicists, you need all of these things to be able to do what we do. So don't feel like if you haven't pursued geothermal at the outset of your sort of academic career that you can't transition into it later. There are so many opportunities that, yeah, for you to apply your knowledge to geothermal systems and geothermal projects.
Thank you all for your contribution today. I personally learned a lot from your perspective, and I hope our audience would also enjoy our conversation.
Thank you so much for hosting this session.
Yeah, thank you, Jesse Ann.
Thanks a lot.
Thank you.